Here are the two lenses and my object, and my scale is 4 centimeters, so each grid represents 4 centimeters. So let's see, that would put our object 12 centimeters to the left of the left lens. The lenses have a spacing of 18 centimeters. The lens on the left has a focal length of 9 centimeters. The lens on the right has a 6 centimeter focal length. Okay, I think we're ready to go. What we're going to do is ignore the second lens. We're going to find the image produced by the light coming from our object and passing through the first lens, and then we'll use that image as the object for the second lens. So maybe I should just erase this one. Let's just get rid of it. Okay, and we'll do our ray tracing now. And once we do the ray tracing, then we'll plug in the numbers and see how it looks. And with a 9 centimeter focal length, that puts our focal length, our focal points here on the axis. I've kind of sketched them in. Alright, so I like to draw 3 rays. That way it sort of is a nice check. If just 2, you're not sure. If you put a third one in there and the 3 lines don't intersect in the same place, you know you made a mistake somewhere. So we'll start with the ray that comes in parallel to the axis. So the one coming from the tip of our arrow, coming in parallel, and I'll use red for that one. And if it comes in parallel to the axis, it comes out through the focal point. Oops. How's that? So that's the first one. The light comes in parallel. It comes out in a different direction, right, through the focal point and continues in that direction. The next ray I'd like to draw is going to come in to the center of the lens and continue through the lens without changing direction. So the light comes in this way and it goes right through the center of the lens without changing direction. And then the third one I'm going to draw comes in through the focal point. About there. And it comes out parallel. So the light comes in this way and it comes out parallel to the axis. And they all intersect roughly right here. That's not bad, actually. The two of them are closer here. And one of them's there. It's not too bad. I'm kind of going to guess it's the point where they intersect is roughly here. And I'm going to draw in oops. Draw in an image there. So let's go ahead and find out what we expect, what the numbers should be using the equation. So we have 1 over the distance, the object distance, plus 1 over the image distance is equal to 1 over the focal length. And let me just jot down what we know here. We know the focal length, this is a converging lens, so the focal length is positive, and it's 9 centimeters. We know the object distance, S, is positive because it's on the side of the lens where the light is coming from, so it's a positive 12 centimeters. We plug those in, solve for S prime, and we get 36 centimeters. So let's take a look and see if we were close. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 40 right here. So I got about 42 centimeters using my my sketch, my ray tracing, and the true answer, the right answer, is 36 centimeters. So I'm a little off. And let's see what the height should be. What we get is an inverted image. Our object was pointing up, and our image is pointing down. So let's check our magnification. That means our magnification should be negative. And our image looks like it's 2 to 3 times larger than our object. So let's see what the magnification tells us. The magnification is negative S prime over S, negative 36 over 12, negative 3. So negative means it's inverted with respect to the object. If the object is up, the image is down, or vice versa. And 3, the magnitude 3 tells us that our image is 3 times as large as our object. So that means it's going to be 30 centimeters. So let me see what I got. I got about 26 centimeters. So, yeah, not too bad for a ray trace, but it should be 30 centimeters in length and located at 36 centimeters to the right of the lens.